Why do honeybees make hexagons when building their honeycombs? It is common knowledge that honeybees create wax combs for storing honey and raising larvae. How come honeybees use hexagons, though? Bees can utilize space very effectively while consuming the least amount of wax by using hexagons. The hexagons fit closely together in a compact manner, holding the most honey while ensuring that no space is wasted. First of all, it should be noted that bees work very hard to create honeycombs. Young bees first exude wax, which several worker bees then meticulously mold into wax cells with perfectly uniform hexagonal shapes. It takes a lot of individual cells to produce a large enough comb to store honey. Honey is the natural food of bees, consumed by colonies during the winter when there aren't enough flowers to forage on. It's also important to point out that some of the hexagonal beeswax cells will be employed to raise their young, and these are called brood cells. Why do the cells have a hexagonal shape rather than a round, triangular, or even square one, for example? In actuality, each cell resembles a hexagonal prism. The cells fit flawlessly, cleanly, and tightly together if all of them are identical and have uniform, straight edges. Since gaps are kept to a minimum, no valuable space is lost, and each cell, aside from the outer cells, has a shared wall with its neighbor. All of this implies that bees can make the most cells possible with the amount of wax available. In 36 BC, nearly 2,000 years ago, a Roman scholar was interested in the topic of why bees choose hexagons over other shapes. Marcus Terentius Varro, a scholar, argued that hexagons can retain more honey than other designs because they divide flat space into smaller units more efficiently and consume less wax in the process. In other words, hexagon honeycombs use the least amount of wax and can retain the most honey. Varro never attempted to truly substantiate his theory, and as a result, it became known as the honeybee conjecture. Then, in 1999, Thomas Hales, an American scientist at the University of Michigan, conducted research and created mathematical evidence that Varro was correct. It's no secret that the human ability to build structures, carry goods, and store goods was influenced by the honeybee's ability to produce honeycomb in the efficient hexagonal shape. However, mechanical and chemical engineering, biomedicine, and nanofabrication all exploit the honeycomb's hexagonal form, which is used in computing, medical and aerospace industries. Snowboards have even been created using honeycomb structures.